In this video, I'm going to introduce exponential growth and decay and relate it to the financial world. So exponential growth and decay can be modelled by a basic rule where we've got y equals ka to the t, where a is the growth rate or decay rate, depending on if we're looking at exponential growth or exponential decay. K is the initial amount and T is the time that it takes to grow or decay. Y would be the amount that you would end up with. So if we were talking about a financial situation, Y would be the amount of money, for example. And I've listed these right here. Now let's look in more detail at A, this growth factor or growth decay. So if A is greater than 0, so if we've got a value of A that's greater than 0, then we can say it's exponential growth is occurring. If A is less than 1, but greater than 0, okay, so I've written an inequality there, we can say that exponential decay is occurring. Now, we will study a lot more within exponential growth and decay in a later video, but within this chapter, we will focus on exponential growth in relation to compound interest and other simple situations involving growth and decay, because in the financial world, it's really important to understand how compound interest works and how investments can grow and decay exponentially. So let's just have a look a little bit more deeply at this growth rate. So if we're talking about a financial situation, we might be talking about a percentage increase of some kind. So this growth rate regarding this formula y equals ka to the x, let's just look at this A. If we're increasing an amount of money, we have a percentage. Now, PA in the financial industry stands for per annum, and it really means per year. Well, that's very important. So if we've been given a percentage that's calculated per year, we know that that's going to increase. We're going to have interest that's increasing. So this relationship here, which is 1 plus r over 100, basically just describes a percentage increase. So say it was, I don't know, a 50% increase, then this A would be 1.5. Now let's have a look at the decay rate, for example. This is really a percentage decrease. So if something's decaying, it's decaying at a rate by a percentage per year. Then if it was decreasing by, say, 80%, we know that the percentage to decrease by 80% is 0.2. Well, let's just check it. 1 minus 80 is going to give us 20%, so it would be 0.2. So these are really, really important formulas. Now, I would be watching the next video on compound interest to get a more deeper understanding about compound interest.